back everybody to our Android starter course. So in the previous video, we had showed how we can use callbacks with the dot and Q function to go ahead and make our async network calls. But in this video, we're going to show you an even better way to do that using something called a coroutine. Now, we basically have three main goals in this video. First is just to introduce you to coroutines. And second, to get you to understand kind of the basic fundamentals of coroutines and how they work. And then three is to actually go into our books tracking application, and we're going to replace our previous asynchronous network call that uses that callback. We're going to replace that with a coroutine suspending function. And to do that, well, yeah, I'll show you how we do that in a minute, but essentially with coroutines, we can really easily manage any asynchronous work, and we can maintain said thread safety at the same time. And now a coroutine is not technically a new thread. It does actually run on a predefined, they do run on predefined thread pools, and they can run simultaneously with each other. They can wait for each other. They can communicate back and forth with each other, and they're actually really computationally lightweight and cheap. And what I mean when I say that they're lightweight is you can actually run many coroutines just on a single thread, and they're easy to cancel. So if I have a bunch of coroutines that are launched by one coroutine, and then I cancel the parent coroutine, they're actually all going to be canceled all the way down. All the children coroutines and the entire hierarchy will get canceled when I cancel the parent coroutine. So this is going to help us to prevent memory leaks, which is definitely something that we want to do in our code, is prevent that as much as we can. It also comes with a suite of extensions that come with the Jetpack libraries, and these provide custom scopes for many of the Android components, such as activities or fragments or view models, etc. Right? That whenever I cancel this component, it's also going to cancel all of the coroutines within that, right? So when the parent's life cycle ends, the coroutines life cycle is going to end as well. So again, no memory leaks here. In an Android application, you basically have two main things that the main thread is responsible for. One is updating the UI and keeping it responsive, updating and displaying stuff on the UI for the user. And then the second is interacting with any input that the user has using that UI. So if we have a UI that we want to update, say at 60 frames per second to make it look nice and smooth, that means we're essentially going to have to call that redraw function to update that UI every 16 milliseconds. So if we want to do that, and then we also want to run a bunch of other tasks and do other heavy liftings and database and network calls and whatever on our main thread, that's gonna it's gonna cause our UI to freeze up, and it's going to cause laggy behavior and potentially even freeze up your UI entirely because you're doing way too much work on the main thread. And let's say I was going through the main thread and I wanted to run a network call, or and actually Android won't even let you run a network call without doing it asynchronously. But let's say I run a network call on the main thread. So I'm updating every 16 milliseconds. And now I get to the point where I do my network call. And when the network call goes through, then it pauses and it waits for the response from that network call, which could take, I don't know, maybe up to a second, maybe 2 seconds, maybe longer. And that whole time, my UI updates have stopped because we're waiting on that response. So that's why we want to run that asynchronously. But beyond that, we also want to run it asynchronously on a different thread pool. And we'll get to that a little bit later. But essentially, before, what we did was we to run our network call asynchronously, we used a retrofit and queue function, and we passed a callback object to that, which was the callback object that we got back from our Books API. But this is not the best way to do that. So we are going to look at a better way to do that using coroutines. And all we need to do is essentially create a suspending function and then launch it in a thread pool. And a suspending function, if you don't know, is just a type of function that can be paused or suspended, hence the name, and then resumed later on. And the only caveat here is we can't execute these from normal, just from anywhere in the code like we can any other normal function. They have to be executed from within a coroutine scope. So we need to create and launch a coroutine before we can launch any suspending functions. So to start here, what we need to do is identify our asynchronous work, which is going to be inside of this enqueue code block here. And you remember we passed that callback object in. So essentially what we need to do is define this async work within a suspend function instead, and then call that from a coroutine. So to do that, let's go on over to our Books API. And within the Books API, we are going to make this a suspending function. So we just add the suspend keyword to that. And then over here, where we're passing the data back for call list book, we actually are now only going to be looking for a list of book objects. We don't need the call because we're no longer going to be using the callback here. So go back over to your view model after that, and we've got some errors because of that. So we need to clean this up just a little bit here. Let's see, up top, we no longer need this books call because we're not doing that. We no longer need this books call.cancel because again, we're not using that callback anymore. And within the get books, I'm going to go ahead and remove the entire body of this function. And we're going to redefine that in a little bit. Let's go up to the top in the view model. And I'm going to add a couple of variables up here. The first one we're going to need is a job. And we're just going to set that equal to a job object here. And that is something that we can use to cancel our coroutine whenever we need. And then after that, I'm going to add a private val scope, and this variable is going to be a coroutine scope. And in here, I'm going to pass it my job variable, and then I'm going to pass it dispatchers.io. And essentially, dispatchers.io is, well, it's one of the predefined dispatchers that's available in Kotlin. The first is dispatchers.main, and that's used for anything that's running, that's just doing light work. That's you're going to be using for it's light, non-blocking, maybe UI updates, that kind of thing. You're going to run within your dispatchers.main. Your dispatchers.io is going to be for either disk heavy or network heavy processes, such as in our case, our HTTP call to our Firebase backend server. So that's why we're using dispatchers.io. And then there's one more called dispatchers.default, and that's going to be used for CPU intensive processes, such as like sorting long things or parsing files and that kind of a thing, parsing JSONs. That's all fairly CPU intensive, so you would use dispatchers.default for that. But here, because we're doing a network call, I'm going to use dispatchers.io. And once we have that in place, we're going to go back down into our getBooks function. And in here, I'm now going to make a new scope, or I'm going to use that scope variable rather to do scope.launch. And this will launch our we'll launch a coroutine with that scope. Go ahead and import that. And then within this coroutine, we're going to do state.value and set that equal to our api.getBooks. Now, this is going to work, and if I run this code, you can see that it will actually do my network call and pull in all of the data for me. So this is working now. We still do have a couple problems here, though. First of all, we are updating our state value right here within our scope, and our scope is assigned to our dispatchers.io, which is for network and disk intensive processes. So really what we should do in here is we should do our network call on the dispatchers.io, and we should do our state.value update on our dispatchers.main. So the way to do that is I'm going to come down here and I'm going to say with context. And then within there, we put dispatchers.main, which is the thread pool that we use for, or the dispatchers that we use for our UI updates. So now I'm going to say, cut that out, say val books equals api.getBooks. And then we're going to say state.value equals books. So that way we're doing the network call within our dispatchers.io, and we're doing our UI update within the dispatchers.main. But then again in here, let's say I had some of these toggled, and so it's different than the value that's coming down from the database, and for whatever reason we ran that network call again. Well, it's going to reset all of these back to what they started at, and I don't want that. So what I'm going to want to do is I need to make a function that essentially I can run on this books, which is a list of type book. So I need to make a function I can run on that to restore all of my data. So we're just going to call that dot restore finished field. And this, to do this, I'm simply going to make an extension function. So I could say private fun list book dot restore finished field. And then we say list book. So it's going to return a list of books to this. And I'm going to need something called a state handle that I can use to essentially get a list of items where everything used to be true. So we're going to go ahead and add that state handle. And to do that, we're going to pass it in up here. So we're going to say private val state handle is going to be saved state of type saved state handle. And now we can use this state handle variable anywhere we want. So down here, I can say state handle dot get. I'm going to get my list of integers, and these integers are going to, this is actually a nullable list of integers. And I'm going to want to get that from the finished field. And then after that, I'm going to use my .let to name that selected IDs. So this is essentially what this is giving me is a list of all of the indexes where this finished field was set to true. So what we're going to do inside here, we're going to say val books map equals this dot associate by it dot id. So we're going to associate it by the id, which is going to associate the new list that we got with the old list. And then down here, we're going to say selected IDs dot for each, and then for each ID, I'm going to name it ID here. And within this block, we're going to say books map ID, make that nullable, say dot finished. We're going to set that equal to true. And basically what this is going to do, we've got our old list associated with our new list, and we're going to go through by each one where the ID was positive, and on each one where we have that ID, we're going to set that finished field back to true. And then after that, all we need to do is in here, let's return our books map.values.toList. And then down here, all we need to do is return this, which is our, and that'll return it to our book trackers view model. And oh, yes, change to var. So we can't reassign our val. If you look in our book.kt, I have them all set as val. So we're actually going to need to change this one to a var so that we can reassign it in our function. And now, if I run that, and if I toggle any of these, it'll go ahead and set those back to what it was before it reran the network call. So a network call won't blow away all of our selections anymore. Oh, and we should actually put job.cancel down here within the onCleared, because that's why we specified that job up here and passed it in for my context. So this is actually gonna run and work. If you look at this app, right, it looks just like it did before. So there's no actual, as far as the user is concerned, functional change here, but we know that behind the scenes, this is running a lot more efficiently and a lot cleaner than it was before. So this is definitely a better approach for that. But we still have a couple things that we're doing that are not best practices that we can go ahead and fix here as well. So the first is we are using a custom defined scope here that I just made a variable for that called a scope. And while we're here, might as well make job private. We're going to delete that in a minute. But anyway, this custom defined scope, so these coroutines are actually very well integrated with some of the Jetpack and Android libraries. So there's some predefined scopes that we can use. For example, there's one called lifecycle scope that's going to be tied to the life of a fragment or the parent activity that it's bound to. Or there's another one in this context that might be a little more useful called view model scope that's going to be tied to the life of its parent view model. And this is, of course, a view model class. So that's definitely one that we want to use. So I'm going to go ahead and delete this job in this scope because we don't want to use the customs. And we can delete this job. Actually, we can delete this entire function down here because if we use the built-in out of the box view model scope, that's already going to get canceled when our view model goes away. So now instead of scope.launch down here, we're going to want to do view model scope.launch. And if we do it like that, it's going to launch it on our on the wrong dispatcher. So we're going to do dispatchers.io again, and this will launch it in the IO and then jump back to the main to update our UI down here. So that will fix that issue. And again, if we run and launch our code, you're not going to see anything different, right? Like this app performs just like it used to. Whoops. Where did that go? There it was. So this app is going to perform just like it used to. There's no functional difference as far as the user is concerned, but this is just a better practice in the code itself, and it's much cleaner, and definitely we want to use those default built-in functions when we can. So the next thing here is we have absolutely no error handling going on here. So what happens if, say, our Wi-Fi is turned off? Let's say we have no Wi-Fi and we have no data. And if I run this app now, it's going to crash. And you can see here, that's exactly what happened. It crashed. And of course, the reason for that is it tried to do a network call. It got an error back and it blew up. So let's think of, actually, I won't turn that on quite yet. Let's think of what we need to do to be able to catch this error. The first thing that we could do is where we're doing the network call, we could simply surround that in a try catch block, catch an exception, and then we'll just print our stack trace. So we could try it like that. Whoops. Like that, rather. But really, actually, we should put all of this within that try catch block. And now if I run this, it doesn't crash. But it also didn't reach it. So you could definitely see here we got an error. Unknown host exception, unable to resolve host, and all of that. And that's, of course, because we have no internet connection right now. But this try catch block isn't necessarily the best solution because, one, we're going to have to do that every single time that we make any network call within this coroutine. Also, we've added another layer of nesting, which just always makes code more difficult to read. So instead of doing the try catch block approach, I'm going to get rid of all of that. Whoops, take that back to how it was. Let's see that. Okay, there we go. So we're back to where we were now, but that's, again, I said there's a better way to handle this, and there's actually something called a coroutine exception handler object, which is going to allow us to handle pretty much any errors that are thrown out of our coroutine after we launch it, and within that coroutine scope object. So this is going to give us access to a function that exposes our coroutine context and, more importantly, any throwable object that comes out of that context. So if we go into our view model and up at the top with our members, I'm going to add a new member up here. It's going to be private val error. It's going to call it error handler, and that's going to be equal to a coroutine exception handler. And we are going to use the lambda block here instead. And so this first field is for the coroutine context. Here I don't care, so I'm just going to hand it an underscore, telling it that we're not going to use that variable. And then I'll hand it an E for the throwable. E stands for, of course, exception. And then in here, I can just do e.print stack trace. So now we don't need to do the try catch blocks on anything. But if we come down here and when we launch our, where is it here? When we do our view model scope.launch dispatchers.io, if we add our error handler there now, so now if we run this program, it's not going to crash. And it's going to go ahead and print out that same stack trace, and we don't have all of that extra try catch block and an extra nesting layer in there to just kind of confuse our code. Let me, obviously this still isn't working because our internet is off, and we're going to fix that and add a local cache in the future. But in this video, we'll just turn our internet back on and get that back to a working state. Well, there's one other thing that we should do here to keep with good practice. We really should ensure that every suspend function that we have is safe to be called from any dispatcher's object. So what I mean by that is we have our API getBooks function here, and that's our suspend function for our get, which is going to pull that books JSON from our Firebase database. But if I were to run that from like a different, right, like say I had dispatchers.main up here, it's like I want this to be safe so that wherever I run it, it's going to default to dispatchers.io always. So basically that's pretty easy to do. I mean, here, because we're only running it one time, it's not really that hard just to type dispatchers.io. But if I was running this 10 times or 50 times or 100 times, typing dispatchers.io can be quite tedious. So we don't want to do that. Definitely there's a better way to do that. And essentially, we're going to create a wrapper for this. So I'm just going to make a new private function, private suspend fun, and we're going to call this get remote books, and this is going to be of type list book. That's what it's going to return back to us. And then within this function, all we're going to do is say return with context dispatchers.io, and then within that, all we need to do is run API getBooks. Now, instead of calling up here within our getBooks function, instead of calling API getBooks, if we just call our getRemoteBooks, now every time we run this getRemoteBooks function or this getBooks function, it's always going to run it on the dispatchers.io and just using this top level suspend function. So because we have this suspend function wrapper, I can now run this from I can run this from dispatchers.main. I can run this from dispatchers.default. I can run it from dispatchers.io. And wherever I run it, it's always actually going to run this network on dispatchers.io because it's a network call and I always want to run it there. So that's just a quick and easy way to fix that. And after doing that, we can also, because we've already defined dispatchers.io, we'll just delete it from up here. We no longer need that. We do still need to pass our error handler. Let's see. Yeah, so because actually our the default launch block up here is going to inherit our coroutine context and its dispatcher object from its own parent object. This is going to run on our dispatchers.main, which means we no longer need this with context block either. So I can delete that. And then finally, our getBooks function looks just like this. And now our code is, of course, much easier to read with it just like that. We don't have all that deep nesting. And even though we're launching our coroutine from our dispatchers.main, it doesn't matter because we're defaulting to dispatchers.io in our wrapper suspend function that we're using down there. And technically, if we go ahead and run our program, again, the functionality has not changed at all. This is going to function just like it did before. But the difference is behind the scenes, we know that using coroutines, we have much cleaner code, we have more efficient code, and we have just a UI that's not going to lock up like it would have potentially before. So this is a much better approach towards building a application, especially a large scale application that you're ever going to publish anywhere. So in this video, we learned how to produce cleaner code and more efficient code using coroutines and also more concise code as well. We learned what coroutines are and how we can use them to launch our suspending functions, as well as what suspending functions are. And we replaced the callback function that we were using in the previous video to run our HTTP call to get our network response. And we replaced that with coroutines. And we finally used our coroutine exception handler to do the handling for all of our coroutines. So hopefully you found this video interesting and helpful. Hopefully that made sense. If you have any questions, you can definitely put them down in the comments below. And if you did find this video helpful, go ahead and click that like button and then also subscribe to our channel to get any additional content that we have rolling out in the future.